Hi, I am Syed on Maths Online. Today I will be discussing about VTU Model Question Paper 2 of 2019-20 CBCS Scheme. Model Question Paper 2 2019-20 CBCS Scheme. Subject code is 18 Mat 41. Question number 4a. Verify Cauchy's theorem for integral over c 1 by z dz, where c is a triangle with the vertices 1, 2, 3, 2 and 1, 4. So the integral is 1 by z dz. We need to verify the Cauchy's theorem for that integral. So the triangle is given with vertices 1, 2, 3, 2 and 1, 4. Let us try to plot the graph for these vertices. So let us take the x-axis and the y-axis. Let us take the point as 1, 2 and 3 on the x-axis and 1, 2, 3 and 4 on the y-axis. So 1, 2 over here you get it. Then you have 3, 2. So 3 and 2 on the y-axis. 3, 2. 1, 4. You have 1, 2, say 4. You just join the lines there. So if you join the points, you get a triangle. Let us take the points as A at the point 1, 2 and B at the point 3, 2 and C at the point 1, 4. So we know from the Cauchy's theorem, the value of the integral f of z dz is equals to 0 over the curve C. We need to show that using the Cauchy's theorem from A, B, C and A, the sum of the integrals along these lines should be 0. So we need to show that integral along AB, the function is 1 by z. F of z value which is there is given as 1 by z in the question. So therefore I will be taking f of z to be equals to 1 by z. 1 by z into dz plus, so the integral along BC 1 by z dz plus integral along the line CA 1 by z dz. So that should be equals to, according to the Cauchy's theorem, that should be equals to 0. So we have to show that sum of all these three integrals is 0. Let us take that as equation number 1. So now let us try to find out along AB the value of the integral along BC and along CA. So let us start with along AB. So along AB, if you try to see what is constant, so along AB the constant value is y. So y is equals to 2. So y coordinate, you can see it is 2 there. So therefore we'll take the value of y to be 2. Differentiate y, so derivative of y will be dy is equals to derivative of the constant 2 is 0. Then the variable term x is ranging from, if you try to see the coordinate of x is ranging from 1 to 3. So therefore x range is from 1 to 3. So 1 by z is a function, therefore we know the value of z. So z is x plus iy, and dz value we know, dz value is nothing but dx plus I times of dy. So now z is x plus iy, but we want 1 by z value, therefore rewrite that as 1 by z is equals to 1 by, the value of z here is x plus iy, x plus iy, but the value of y along AB is 2. So try to plug in the value of y to be equals to 2. So along AB 1 by z dz will be equals to, so it is integral x is ranging from 1 to 3. So x value will be equals to 1 to 3. So it is 1 by z value is known, it is 1 by x plus I times of y, y value is 2. So it becomes x plus 1 by x plus I into the value of y is 2. So therefore we will be getting 2i, and dz value will be equals to dx, because dy is 0, therefore dx plus 0 will be dx itself, because dy has become 0 there. So 1 by z, z value is here x plus 2i into dz, dz value is dx, so write down that value as dx. Now if you try to integrate this one, this is in the form of 1 by x, so 1 by x integral will be log of x, so therefore it will be log of x plus 2y, and limit values for x will be x is equals to 1 to 3. So now you can apply the upper and lower limit values. It is x value is 3, so 3 plus 2i minus the lower limit value for x is 1, therefore you get log of x is 1, so 1 plus 2i. So we applied the upper and lower limit value. So integral along AB 1 by z dz will be equals to the log expression. Now let us try to find out along the line BC. So you can see in the figure it is along the line BC. So along this BC, so you can see along BC x is also varying and y is also varying. Both x and y coordinates are varying over here. So therefore we'll try to find out the equation of the straight line along BC. So we'll try to find out the equation of the straight line, BC passing through 2 points. So the 2 points over here are x1 comma y1. So the first point is 3 comma 2, and x2 comma y2. The second point is C is 1 comma 4. So we know the equation of a straight line passing through 2 points, x1 comma y1 and x2 comma y2. So therefore the formula is y minus y1 divided by x minus x1 is equals to y2 minus y1 divided by x2 minus x1. So just plug in the values of x1, y1, x2 and y2. So we have y minus y1 value is 2 divided by x minus x1 value is 3. is equals to, it is y2 minus y1, which is 4 minus of 2, divided by x2 minus x1 is 1 minus of 3. So let us try to simplify this expression. Y minus 2 is equals to, cross multiply that x minus 3 on the other side. Now subtract it. 4 minus 2 will be 2, divided by 1 minus of 3 will be minus of 2. You can cancel out the 2. You will be left out with minus sign there. So therefore we will be getting minus of x, multiply that minus sign inside, minus of minus will be plus 3. So you got minus x plus 3. Left hand side y minus 2. So y will be equals to minus x as it is, plus 3 as it is, minus 2 goes on the other side, becomes plus 2. So y will be equals to 3 plus 2 will become 5. So first I'll write the positive value 5, then minus of x. So we got y is equals to 5 minus of x. So we have expressed y in terms of x. Try to differentiate that one. Dy will be equals to derivative of y, the constant will be 0, minus derivative of x will be dx. So now you can see x limit values from the figure. So x value from the figure will be nothing but, if you try to see, x1 is 3 and x2 value is 1. So the range will be from 3 to 1. Now if I write down the function 1 by z value and try to plug in these values that we have, therefore 1 by z will be equals to, it is 1 by, we know it is x plus iy, that is equals to 1 by x as it is plus I times of y value, we know it is 5 minus of x. So it is I times of 5 minus of x. So x, you can just multiply that one, 1 by, so if I take x common outside, because there are two terms for x if I take common there, 1 will be left out. Here if I take x common, it is minus of I will be there. So we will be getting minus of I. And you can multiply this I with 5, so we will be getting 5 times of I plus 5I. So further if I try to rewrite, 1 by z will be equals to 1 by 1 minus of x, I will write first, into, you can write down x as it is, then plus 5I as it is. And then dz value, we know it is dx plus I times of dy. So let us try to dx as it is, dy value, we know it is minus of dx. So let us write down minus of dx. If I take dx common outside, I will be left out with 1 in the first case, and plus I into minus of 1 will be minus of I. So therefore we got 1 minus I times of dx. Now write down the integral along BC. The function is 1 by z into dz will be equals to. So along BC we have the integral, x value is ranging from 3 to 1. It is from 3 to 1, the range for x. Right, so 1 by z value is known. It is 1 by 1 minus I times of x plus 5I into, you have dz, 1 by z into dz. Dz value is known. It is 1 minus of I into dx. So write down 1 minus I as common outside. You are left out with integral x is equals to 3 to 1. Dx is there, dx divided by, write that expression as it is, 1 minus I into x plus 5 times of I. Now this integral is of the form dx by x, which will be nothing but log of x form. So we know the standard formula, that is integral of dx by ax plus b. If it is of this form, we know the formula. The formula will be log of ax plus b divided by the coefficient of x is a. So divided by a. So that's the formula we have. So dx by x plus b will be log of ax plus b divided by a. So you can use that formula here. So now 1 minus of I, the constant as it is. So now the formula will be log of 1 minus of I times of x plus 5 times of I. This whole divided by coefficient of x is 1 minus of I. And the limit values that we have, limit values for x will be equals to 3 to 1. So it is 3 to 1. So 1 minus of I and 1 minus of I will cancel out. Apply the upper and lower limit values for x. The upper limit value for x will be equals to 1. So 1 minus I times of x value is 1. So you just be getting only 1 minus I itself plus 5I as it is. Minus of the lower limit value for x will be 3. So we'll get log of x value will be 3 there. So 1 minus I times of 3 plus 5 times of I. So therefore it is log of, you can just write down 1 as it is. You have minus of I there and plus 5I. So 5I minus of I will be 4I. So 1 plus 4I. Then minus of, you have log of, you just multiply that 3 inside. So 3 times of 1 will be 3 minus 3 times of I will be 3I. So it is minus of 3I, you get it, and plus 5I. So if you try to subtract it, 5I minus 3I will be 2I. So plus 2I you will be getting. So hence you got log of 3 plus 2I. So now we have to calculate along CA. Along CA, if you try to see the coordinate for x is constant, so x will be 1 along CA. So that's the constant. So let us take that x to be equals to 1 along CA. So along CA, the value of x will be equals to 1. So let us try to differentiate this one. Derivative of the constant 1 will be 0. Then if I try to see the variable limit for y variable limit, if you try to see the figure, so in the figure the value of y is ranging from 4 to 2. So therefore you can write from 4 to 2. So now the function that you have is 1 by z. So 1 by z will be equals to 1 by, the value of z is x plus iy, that is equals to 1 by x value is 1 plus iy. So 1 by z value you got it as 1 by 1 plus iy. Dz value will be equals to dx plus I times of dy. But the value of dx is 0. So therefore you get that value to be 0. You are left out with I dy. So dz value will be I times of dy. Now if you write down the integral over CA, 1 by z dz will be. Now along CA the value of y is ranging from 4 to 2. So 1 by z value is known, it is 1 by 1 plus I times of y into dz. Dz value is I times of dy. You can take that value of I common outside. You will be left out only with 1 by 1 plus iy into dy. So now it is in the form of 1 by x, therefore its integration will be log of 1 plus iy. It is divided by coefficient of y. Coefficient of y is I, so it will be divided by I. This formula is similar to the formula that I have done along BC. So therefore the limit values will be from 4 to 2. So I and I will cancel out. Now we'll try to apply the upper and lower limit values. So it is log of, the upper limit value for y will be 2. So therefore we'll be getting 2 times of I, minus the lower limit value for y will be 4. So we'll be getting 4i, 1 plus 4 times of I. So you can see that we have obtained along AB, along BC and along CA. So you have to just plug in all the values that you obtain in equation number 1 and show that the right hand side value is equals to 0 to prove the Cauchy's theorem. So all these three values have to be substituted in equation number 1. So therefore I'll just be taking the left hand side value. So therefore you can take from equation number 1, I'll take the left hand side and arrive at the right hand side and show right hand side as 0. So you have along AB 1 by z dz, the left hand side, integral over BC 1 by z into dz plus integral over CA 1 by z into dz. So you have along AB, the value of the integral that you have is, you can just check along AB, the integral is log of 3 plus 2i minus log of 1 plus 2i. So that value you can plug in here. So we will be getting log of 3 plus 2i minus log of 1 plus 2i. Now the integral along BC. So BC, you already know the solution that you have got is log of 1 plus 4i minus log of 3 plus 2i. So that is the integral along BC 1 by z dz. So that's the value we have. So we'll try to plug in that value. So log of 1 plus 4i minus log of 3 plus 2i. Now along CA, just now we have got it, along CA it is log of 1 plus 2i minus log of 1 plus 4i. So just write down that value, plus log of 1 plus 2i minus log of 1 plus 4i. So if you try to observe the values over here, you are having plus log of 3 plus 2i and minus log of 3 plus 2i. Those two values will cancel out. Then you have minus log of 1 plus 2i and here plus log of 1 plus 2i. Negative and positive value will cancel out. Next value you have log of 1 plus 4i positive value minus log of 1 plus 4i negative value. These two values will cancel out. Since all the values have been cancelled out, you will just be getting the value to be equals to 0. So that is equals to 0. So that is nothing but the right hand side of equation number 1. So hence we have proved that LHS is equals to RHS. So which means that we have verified the Cauchy's theorem. So hence Cauchy's theorem is verified. Hence Cauchy's theorem is verified. Hence Cauchy's theorem is verified. So that's all I have for today. Thank you.